Hello learners, welcome back to Education Program Online with me, Teacher Christine, still taking you in Maths for Senior 3 and Senior 4. So we are still continuing with our topic of real functions and limit. But at this moment we are going to look at what we call operations or operations on functions. Operations on functions. Operations on functions. Operations on functions. So operations on functions is what we are going to look at the moment. When you look at what we call the operations, there are majorly 4 operations in mathematics. That is additional, subtraction, multiplication, and division operation. So with all these 4 operations, we are going to apply them in functions. And how do we apply them in functions is what we are going to see. So you say there are mainly 4 operations on functions. 4 operations on functions. 4 operations on functions. They include 1, they will say fx equals to f plus g of x. And then we have 2, fx equals to f minus g of x. And then we have f3 fx equals to f times g, f times g of x. And then number 4, we have fx equals to f over g x. So these are the operations. Now when you are going to deal with the operations, you will find that the first operation is addition. That involves the composite functions. So this addition, they have said f plus g of x. So what does it mean? It means that when you are dealing with the operations, you first get yourself alone and then put yourself on the other one. That is what it means. You get a function f and then add it to function g. Function f, add it to function g. In your working, you will simply say, I will express as fx plus g x in that way. And then we come to fx minus g x minus g x. And then we have look here, in your exams or in your papers, they will always say f then small 0. That is small 0 is the same as saying f times g, or any function that is given. As long as there is a small dot in between them, it means it is a multiplication operation. So you will also put it as fx times g x. And then this one will be fx divided by g of function a. So this is how you'll simply express your operations. Then now, how do we use them, apply them? We look at the example. So when we look at the example, the question says, given that fx equals to 3x minus 4 and gx equals to 2x minus 1, 2x square minus 1. So then they say find a f plus gx, b f minus gx, c they said f plus g2, d we have f gx, e we have f minus 3 gx, and then lastly we have f of negative 1, and so on and so forth. So after you have understood all this, my dear learners, you will be able to answer any question on operations. Let us look at the solution part. The solution part for part A. So they said f plus g, add the function f and together with the function g. So you come back down here to your rules which are given. What is the value of function f? What is the value of function g? Then now you substitute. But before you substitute, what you do, you simply expand that as a function of its own. So f plus g of x is the same as saying I will have function x plus function g of x. So you expand it in that form so that it becomes easy for you to substitute. So you here it means you are going to write to substitute the function of f, which is 3x minus 4. 3x minus 4. You can even put them in bracket so that it becomes easy for you to deal with the signs. And then now here is plus function g, which is 2x square minus 1. Then you also put it in that way so that it becomes easy for you to collect the like terms. Now here we find that when we are adding, you are to add things which look alike. Things which look alike are the ones that you add together. Things which are not alike, they cannot be put together. So for this case, we find that here is containing a variable which is yes, and here is also containing a variable which is true. But when you look at the variable of this, it contains a power. Therefore, it cannot be added just because of this power. It makes a difference. So you simply now have 3x When I open the bracket of the other side, I will get positive 2x square. Positive 2x square. And then I will come to the constant here, which is minus 4. When I open in a positive and a negative gives us negative 1. Then now from there you find that you have 3x plus 2x square minus 5. Minus 5. So you cannot leave your expression in that order because it looks disorganized. So you arrange according to the power. Which one contains the highest power should be addressed first, and then it goes in that order. So when you look at here, you find that x plus 2x square is the highest. Then now you come and say, therefore, f plus g of x equals to 2x square plus 3x minus 5 as your answer. So your answer will be like that. That is under operation of addition. And then we go to part B. So part B says f minus g. F minus g. We have B, f minus g of x. So we said expand this or express it as independent function. You say fx, you can even say close the bracket, it is independent, minus g of x also, which is independent. Why we are putting this bracket? Because students always find it difficult how to deal with the integers. So, but when you put your things in that bracket order form, it becomes easier for you to deal with the integers. That is the science of this is science in mathematics. And then now you substitute. What is the function x? Is given as 3x minus 4. 3x minus 4, close the bracket, and then minus function g, which is 2x square minus 1. So close the bracket, and then now you'll now begin to subtract. So we say still, especially addition and subtraction, you cannot subtract things which are not the same. You only subtract things which are the same. No matter here, when you look at here, we find there is a variable, and here also a variable. Look at their degree. Do they all have the same degree? If they have the same degree, then you can add or you can subtract. But if they have different degrees, then they are different. So we say we shall have 3x minus 4. Now, for you to open this bracket, we use the sign here out. So you say negative times a positive 2x square will give us negative 2x square. And then this negative times a negative will give us a positive. So that's why I encourage you to use the bracket, because if the brackets are not there, you will easily mess up here on how to deal with the to get the sign here. You may continue with the negative when it is supposed to be a positive. Now from here you can now arrange them in the order. So you will have negative 2x squared, negative 2x squared, and then we have positive 3x, and then now we have negative 4, and then we have positive 1. So what will happen? You will now simply say f minus g of x will now give me negative 2x square plus 3x and then minus 3. In others, you may either alternate the signs here. This one becomes a positive, and then the middle term becomes a negative. So the one that is easy for you, you'll take. So you will say my answer is that, or you will simply say I will have positive 2x square plus minus negative, they interchange, and then you will have in that form. If we are to follow, arrange according to the powers. So this is how you will simply get your operation on addition, subtraction. And then now we come to part C. So part C says F plus G. Part C, F plus G when x is 2. So when x is 2, still don't rush and say, now I'm going just to substitute straight the value of x in the equations or in these functions. What you do, first express, deal with this first, the two functions, the composite functions. After you have done with it, that's when now substitution will come in. Because you can even see here, it is telling us that 2 is in a bracket, and then the one outside are also matching together. So you simply say I will have fx plus gx, and then when I substitute it, I will get 3x minus 4, and then plus 2x square minus 1. So for this case, automatically we get our post 3x minus 4 plus 2x minus 1. Then now we arrange them. We say we have 2x square plus 3x, and then minus 4 minus 1, which will give us 2x square plus 3x minus 5. It is at this level, when you have shown clear up to this level, it is at this level where substitution will take place. Then now from this point, you are now going to do what? You substitute now the value of x. Then now you come and say, therefore, f plus g when x is 2 will now be 2 into 2 square plus 3 times 2 minus 5. So that is how you express, and then now here you get 4. So we get 4 plus 6 plus 6 minus 5. So this will be 8 plus what? Plus 6 minus 5. So 8 plus 6 gives us 14. 14 minus, this will be 14 minus 5. So 14 minus 5 gives us 9. Then now 14 minus 5 gives us 8. It is 9. So you simply say now, therefore, f plus g2 equals to 9. So this is your answer. So learners, that is how you simply deal with such kind of operations. Now when it comes to multiplication, that is part D. So the multiplication in part D, you simply say f0 times gx is the same as fx close times gx close the bracket. So when we substitute this, we get 3x minus 4 times 2x square minus 1 minus 1. So when we are multiplying, it means that we can decide to take one of the factors here to be a common factor. Then, but if that one is confusing you, we can simply say 3 times 2x. 3x times 2x square will give us 6x cube. So this will give us 6x cube. Why we say cube? Because we have x times x square will automatically give us x cube. And then we have 3x times negative 1. We get negative 3x. And then we also move to the second number. That is negative 4 times 2. We get negative 8. And then negative 8 times x square, we get negative 8 square, negative 8x square. And then we have negative 4 times negative 1, we get positive 4. So from that level, we can now collect our like terms. We have 6x cube. When you look at this power and this one, you find this one is power 1, this one is power 2. So minus 8x square will follow, and then minus 3x, and then plus 4 as your answer. Then now you say, therefore, f times x of this will give you this answer. So that is how you simply do with your multiplication. So with part E, let us look at part E. Then part F, I will hope that you will also try part F. So when we look at part E, so part E is, they have said F minus 3g of x. What does it mean? It means you are going to have function f minus the constant 3 times function g. That is what it means. So when we substitute this, we get 3x minus 4. 3x minus 4, and then 3 into 2x square minus 1 minus 1. Then now you first, before you operate, apply your operation here of subtraction, you are going to do what? You will first simplify this part. This is bracket here. So you will have 3x minus 4. So when we open the bracket, we say 3 times this. So let us put here so that everyone can see what we are doing. Minus 1. So if we are to open the bracket of this, we are going to multiply 3 times each element inside the bracket. Then we have 3x minus 4 and minus 3 times 2, we get 6x square. And then negative 3 times negative 1, we get positive 3. So it will give us in that form. So now from here, we can easily now do what? Collect our like terms. We have 3x, and then we have minus 6x square, and then we have minus 4, and then plus 3. So from this, we simply now say, if we follow the order of the degrees, we shall now have our final answer as minus 6 raised to 2, and then plus 3x, and then negative 4 plus 3, we get negative 1. So this will give our answer for part E, which is f minus 3g of x. So learners, that is how you automatically play with the operations of on functions. Then the last one, I hope you can now be able to do what? To try number f. Number f was f of 1. So for this case, since we have already the product, you follow the same steps up to here. So when you reach to this stage, that is where you do your operation or you substitute now the value of x. So you simply have f plus times g of x. Now in this point, you say this is 3x minus 4 times 2x square minus 1. Minus 1. So when we multiply, we get 6x square. 3x times this, we get 6x square. 3x times negative 1, we get negative 3x. And then negative 4 times this, we get negative 80x square. Negative 4 times negative 1, we get positive 4. So learners, at this level is where you can now do what? You substitute. You come now down and say, if x is 1, if x is 1, what will happen to this function? So you will get 6 times 1 square, and then minus 3 times 1, and then minus 8 times 1 square, and then plus 4. So this will give us 1 times 1 will get 1, times 6 will remain with our 6. And then negative 3 times 1 we get negative 3. And then here we have 1 times negative 8 we get negative 8. And then plus 4. So from here now we find that we have two integers, the negatives and the positives. So what you do, you get the positive together, you get the positives together, and then you bring the negatives also together, so that you can now have here as 10 plus what? Minus 11. So 10 minus 11 will give us less by 1. We get negative 1. Then now you come and say, therefore, f times g when x is 1 is equals to negative 1. Dear learners, this is how you play with your operations. Sometimes if they say division, you also do the same. With this, my dear learners, I think you have picked something on operations of functions. So with the operations of functions, what you need to identify is which operations have they given you, and what do you do if the operations are given. Make sure that you treat each function as independent function before you do what? Before you begin to work out it. And then once you have followed, you have taken that into consideration, the operations becomes very easy for you. With this, my learners, I hope you have picked something in operations of functions: addition, subtraction, multiplication, and division. With this, we have come to the end of our lesson. But before we close up, I want you to take these two questions as your homework exercise. Please take this as your homework exercise. Say if fx equals to x squared plus 3, and then gx equals to x squared plus 2x plus 3. Find a f plus g of x, b f minus g of 2, and then c f times 3 of 3, and then lastly d 2f minus gx. So learners, let me add UE, that is fx over gx. So learners, go and try to attempt these questions. And with this, I can say we have come to the end of our lesson today, and I wish you the best. Thank you so much for your cooperation. Goodbye.